Assalamualaikum and hi. Before we start our topic today, let us introduce ourselves first. So, my name is Nitnur Ada Farina binti Nilm Amin. My student ID is 2024242504. Our program code is CDCS143. Our course code is MAT263. And our course group is P1CDCS 14314.
Hi, my name is Noor Afifah binti Ashari, student ID 2024-660-983.
Hi, my name is Noor Najah binti Awang Ida Junaidi. My student ID 20244-32854.
Introduction of the study for Gauss-Jordan elimination. Amora Cafe focus on selling 3 types of donut, which is chocolate, vanilla, and strawberry. These donuts are prepared and sold daily. There is 3 main ingredients such that flour, sugar, and eggs. Based on the recipe, this ingredient must be combined differently for each variety of donut. To make sure the efficiently calculation must manage the relationship between ingredients and donut produce can be represented using system of linear equation. The Gauss-Jordan elimination method is suitable to determine the number of each type of donut produce. Now we go for the purpose of this study. First, to calculate the number of 3 flavors of donuts that can be produced on the available amount of flour, sugar, and egg. Second, to represent the relationship between ingredient and donut in system of linear equation for business operation. Third, to show that the application of Gauss-Jordan elimination method can solve problems in our.
Now we move to the methodology. In this case study, we use 3 types of donuts, namely chocolates, vanilla, and strawberry donuts. The main ingredients is flour and sugar. The relationship between these ingredients can be presented as a system linear equation. Next, the Gauss-Jordan elimination method is applied to solve the system and find the value of the relationship between the ingredient is represented by a system of linear equation. Here, X represents the number of eggs, Y represents the amount of flour in kilograms, and Z represents the amount of sugars in kilograms. The system of equation is x plus y plus 2z equal to 15. And number 2, 2x plus y plus z equal to 18. And the last one, x plus y plus z equal to 20. The system is solved using the Gauss-Jordan elimination method. First, the equations are written in augmented matrix form. Next, elementary row operations are performed to obtain the reduced row echelon form. Finally, the reduced matrix is converted back into a system of linear equations to determine the solution. Next, we solve the given system using the Gauss-Jordan elimination method. In step 1, the system of equations is converted into an augmented matrix. The row of a matrix is 1, 1, 2, 15, 2, 1, 1, 18, 1, 1, 1, 20. In step 2, we make a 0 below the first leading one by performing row operation row 2 minus 2 row 1 give row 2. And as a result, the second row becomes 0, -1, -3, and -20. In step 3, we make another 0 below the first leading one by performing the row operation row 3 minus row 1 give row 3. And as a result, the third row becomes 0, 0, -1, -4. We make a 0 above the third leading entry by performing the row operation row 2 minus 3 row 3 give row 2. As a result, the second row becomes 0, -1, 0, and -3. In step 5, we make another 0 above the third leading entry by performing the row operation row 1 plus 2 row 3 give row 1. And the first row becomes 1109. In step 6, we make the second leading entry equal to 1 by performing the row operation negative row 2 give row 2. As the result, the second row becomes 0103. In step 7, we make a zero above the second leading one by performing the row operation row 1 minus row 2 give row 1, and as the result, the first row becomes 1, 0, 0, 6. Finally, in step 8, we make the third leading entry equal to 1 by performing the row operation negative row 3 give row 3. As a result, the matrix is now in reduced row echelon form. Converting the matrix into a system of linear equation gives a unique solution of the system, where x equal to 6, y equal to 3, and z equal to 3. Therefore, the Gauss-Jordan elimination method has successfully solved the system of linear equation.
Okay, now I want to show the result of our case study. After using Gauss-Jordan elimination method, the solution will be obtained. The 8, which is x equal to 6, flour, which is y equal to 3 kilograms, and also sugar, which is z equal to 3 kilograms. For our discussion, we get 8 has the highest amount of ingredients used in donuts productions, indicating it should be prioritized in donuts production. Next, flour and sugar has the same amount of ingredients used in donut productions. This approach ensures decisions are based on quantitative analysis rather than subjective judgment. In conclusion, this case study shows that linear algebra offers an effective and organized approach to calculating the precise quantity of egg, flour, and sugar required for the donut production. By representing the ingredient requirements as a system of linear equations and solving them using the Gauss-Jordan elimination method, bakers can accurately identify the amount of each ingredient needed. This approach can also be applied to other bakeries or businesses facing similar challenges in determining the exact quantities of ingredients for their products.